Hello students, let's examine topic 5's protecting digital systems and data. 5.3.2 is the subtopic heading. This is from Edexcel GCSE Computer Science. There are a number of issues related to this. One is to do with forms of attack. So the different forms of attack that could potentially breach data in a digital system would be brute force. I mean, essentially, if you found someone's luggage and you've got 3 little wheel numbers, you could try every combination, couldn't you? And brute force would literally go through 000 all the way up to 999 until it found the correct combination, and eventually it will unlock your luggage. So brute force, usually automatic attempts to get unauthorized access. Then we also have denial of service. Okay, so denial of service are quite popular because they pretty much always work. So if you flood a server, let's say you've got a computer server in some warehouse somewhere, data center, serving a website, let's just say it's M&S, and you didn't want M&S to have their website working for any point of time, then you could flood that server with requests in millions and millions and millions of requests, requests or packets of data, and the server will just go, right, I can't deal with all of this, and the whole website will grind to a halt, or that service will grind to a halt. Another one would be a botnet. So literally short for bot, net, 2 words. So a hacker will infects a zombie device. It could be someone's laptop that they don't really realize is being used, and then they can use that device to anonymously send out spam to other people. This is quite typical because people probably don't even realize that their computer's doing this. It's all happening sort of behind the scenes. And typically these are used to mine cryptocurrency, which is obviously it's so difficult to mine digital currency, because there are lots of really complicated, essentially mathematical calculations that have to be done. It takes time. So if you've got thousands and thousands of other people's computers doing it for you, so it's typically what's used there. Farming is another one. So a cyber criminal install malicious code on your computer. So let's just say that's your laptop. Bad code on your computer, and it will redirect traffic, I'll put web traffic. It's going to redirect web traffic to a fake, a sort of fake official looking website. So it could be, it might look like Amazon, but it's actually not Amazon at all. Or it could look like a bank and actually not be a real bank at all. So then someone tries to log in because they think it's legitimate, and then their information is harvested. So you want an up-to-date virus check for this. For denial of service, to prevent this, you want a firewall, which essentially allows you to block certain ports on your computer. Just some sort of brick wall here. So each brick could be like, I don't know, port 43 or something like that. And a port will correspond to a service could be something like FTP. It could be something like email, like SMTP. I think it's 443. So if you can turn off those ports or change the value of those ports using a firewall, that's quite a good way of stopping a denial of service attack. It's not foolproof, but you can help. Port 80, by the way, is usually like Apache server's default port for internet traffic. So, changing that port to say, I don't know, something random like 90 could actually be quite good, because a lot of these systems can be automated. To stop brute force attacks, you can get strong passwords. Strong passwords really help. Botnets, virus checker. Virus check. I'll put up to date. And for farming, encryption. Now, encryption means you take your data and you modify it somehow so it's difficult to see. Oh, hang on, no, not for farming. What am I talking about? Farming, up-to-date virus checker. For encryption, I'm getting ahead of myself. There's another type of attack, which would be what we call man. Let me just zoom up here. In the middle, sometimes abbreviated as MITM. So this, let's say you've got your computer, and you're talking to someone else. Someone is looking at your information there. It's like an eavesdrop. And to stop that eavesdropping from happening, you want to use encryption, so you can kind of padlock it, if you like. So even if they can look at it, it's hard for them to see. Now, if you're sending large sums of money, sometimes that information is encrypted. It should be. Sometimes using even quantum algorithms, which are, as soon as you look at them, they fall apart, which means we know someone's snooping at it. There are things like MD5 checksums as well for to make sure that all packets to do with the file have been received. That won't be in your syllabus though, so don't worry about that. Let's have a look at some exam questions. Students are asked to sign an acceptable use policy, because one of the other aspects, there's quite a lot of detail here, one of the other aspects of protecting digital systems is this idea of, and I'll write it over here, AUP, acceptable use policy. So at your school, you might have been asked to sign, or your parents sign, an acceptable use policy. Explain one way that an acceptable use policy helps to protect student data. Well, you could say students are deterred from unsafe practices. They might not be allowed to go on YouTube or Roblox or something like that. And the main crux of this would be an acceptable use policy is activities are defined, like what you can and can't do. They're set out at the beginning. So allowing people to follow safe practices, something like that. So that they're defined somewhere in a user agreement. If you use the computers at school, you're not going to be creating content that could harm somebody else. You're not going to send a nasty email to somebody, or using it to try and hack into the system somehow. These are all things that you would have in an acceptable use policy. Also, places like libraries or or public Wi-Fi, an acceptable use policy for public Wi-Fi, like you're not going to use it to view something nasty or use the service to harm other people. Like cybersecurity protects systems from harm, right? Explain one reason why an acceptable use policy keeps computers secure. So essentially same sort of thing I've just been talking about. I'm just going to sort of abbreviate here. So rules, you can follow rules. Keep files safe, for example. Users deterred. So deterred from unsafe practices, because this is an explain. We've got like 2 marks here. Because rules are laid out ahead of time, something like that. So there's quite a lot to take in there, different forms of attack, what you can use to mitigate those. But as you can see, the 2 exam questions are about acceptable use policy, so hopefully you've got an idea now. I mean, you've all agreed to them. I'm sure you've been at Starbucks and you've agreed to the public Wi-Fi acceptable use policies there.